So what we are going to be looking at is integration by partial fractions. We are going to integrate using partial fractions. We're going to rewrite this part as x minus 5 on one side and our a's on the other. So we're going to have a over, let's just use this first bracket, x plus 1, and plus b over the second bracket, x minus 2. So we are now going to cross multiply this so that we have x minus 5 is equal to a times this one's bracket, so x minus 2 plus b times that bracket, x plus 1. And then we want to eliminate a, and then we want to eliminate b. So let's start with a first. We want a 0 here. So to get 0 out of this, we plug in, substitute the value of 2. Thank you. So when x equals 2, what do we have? We have 2. We have to put 2 in here as well. So 2 minus 5 is minus 3. And then that becomes 0. So it would be a0. You could just write it as a0 for now. What happens here? We have 2 for our x. So 2 plus 1 is 3. So we have 3b. So essentially, we have minus 3 is equal to 3b, which means that b would be equal to minus 3 over 3, so therefore equals to minus 1. So that's our value of b. Then we look to eliminate the b itself so that we can find a. So here we want a 0, so we'll have to have minus 1 in here. So when x is equal to minus 1, so we put minus 1 in here too, so minus 1 minus 5 is minus 6. What happens to the a? Minus 1 minus 2, it gives us minus 3. So a is minus 3 and a here. Well, a is at minus 3, but it's minus 3a, yeah? The b, what happens to the b? That becomes 0, because minus 1 plus 1 is 0. So b is just like that. So essentially, you have a is equal to minus 6 over minus 3, which is positive 2. So you find your value of b as minus 1 and your value of a as 2. Next, you can go back and rewrite this whole thing. So you could have, so a is 2, so 2 over x plus 1. B is minus 1, so minus 1 over x minus 2. And you are going to integrate that. Okay? Now, this one, the integration of that will be straightforward. It will just be ln x minus 2. However, this one, you should use your consideration, your reverse chain rule, yeah? So let's quickly do that. So we are going to consider y is equal to ln x plus 1. And when we differentiate that, what do we get? We get the differential of this, which is 1 over x plus 1. And as you can see, we need a 2 here, so we're going to multiply this by 2 when we integrate, okay? So it's going to be 2 ln x plus 1. Right, so this is what we have, and we can write our plus c here. So next, we want to rewrite this. So we can move this with a power here. So we can have ln x plus 1 squared minus ln x minus 2 plus c. And finally, we can combine these two as bracket x plus 1 squared over x minus 2 and plus c. And that's our final answer. All right, so have a look at this one. We have 8x squared minus 19x plus 1, and then we've got this denominator, which has a repeated bracket. Now, we've got 3 brackets here. We are going to do this using a, b, and c. But have a look at the denominators so you can follow what happens when you have something like this. So you have 2x plus 1 on the first one. You have x minus 2. And you've got another x minus 2. And you're going to put that with the c. But you're going to square it. And the reason we square it is because when you multiply it out, you want to make sure that you end up getting that. And you can check that, okay? So that's the system that you follow, yeah? Okay, well, that's a good system to follow. You can be in any order, but that's a good system to follow. Right, and we'll do everything as normal that we did previously in the previous example. So we have 8x squared minus 19x plus 1, and that's going to be a. Now, what bracket does a need? It's got that, so it needs x minus 2 squared. Very good. And b, it's got one of those. It needs one of this and another one of those to make the x squared, yeah? So it will be 2x plus 1 and x minus 2. Finally, squashing c in here. What does c need? It's got the square, so that's taken care of. It just needs that bracket there. So 2x plus 1, okay? And then we go through it. We start substituting values of x to eliminate one of the letters each time. So let's start with something nice and simple. Maybe this one. So to eliminate a, what would we need that to be? We need that to be a positive 2. So when x equals 2, can you substitute 2 in here for me as well, please? And let me know what the result is. We get minus 5 for this. We get a as 0. Can you substitute the 2 in here? Well, obviously, when you substitute 2 in here, that's a 0, right? So it's going to make this whole thing multiplied out to be a 0 as well. So it's just c I need, please. So what does the value of c give me when I have 2? 5. So 5. So essentially, I've got minus 5 is equal to 5c. So therefore, c would be equal to 1. Sorry, minus 1. Because minus 5, yeah? C would be equal to minus 1. All right. Next, so we've done c, we've found c. Let's actually eliminate c itself. We've got 2x plus 1. What would x need to be here? It would need to be a half. A positive half, negative half? It would need to be a negative half. So once again, can you substitute half in here and here as well, please? And let me know what's on this side. So you got 25 over 2 on this side, yeah? So let's put that in decimals. So 25 over 2 would be 12.5, yeah? What do we, so c is gone, obviously, because we're eliminating c in here. So what does a give us? And b would be gone as well, because that's also got that same 2x plus 1. So this would be a 0, multiplying this out. So what's a? 6.25a, thank you. So therefore, what would a be equal to? It would be 12.5 divided by 6.25. So that gives us 2. So a is equal to 2. Now, how would I find b? Problem is, I've got both those brackets here, so if I make any of those x values what I have, it will get rid of b completely. All right, so let's sub in 0. So when x equals 0. So when x equals 0, what do we get here? 1. So when x equals 0, what do we get for this one? For a. When x equals 0, what do we get here? Minus 2b. When x equals 0, we want to find our value of c. What do we get? Just c. Yeah, 1c. Now, we know the values of a and we know the value of c. So now we can do our substitution. So 1 is equal to 4 times a. A was 2. So 4 times 2 is 8. Right? We know the value of, we don't know the value of b actually. So 2b plus c, we know c is minus 1. So now we have minus 2b minus 1. Okay, we just substituted our values of c and a in here. So we'll work this out. So let's take the minus 2b to the other side. So we can have 2b here. Let's take the 1 over to this side. So we've got 8 minus 1, which is 7. And then minus another 1, which is? So b would be equal to 3. So now that we've got our values of b, a, and c, we can go back here and substitute them in. So if I just replace all of them with their corresponding values. So a is 2, b is 3, and c is minus 1. Now, this is going to change, and that can just be minus 1. So I will be integrating that. So I'm going to get rid of all of this, and then we're going to start the process of integration for that, okay? So let's just do that. So we are going to be now integrating this. Once again, you've seen what happened previously when we use ln. We need to consider. We always should consider things, okay? So when y is equal to ln 2x plus 1, dy over dx is equal to what? So what do we get here? We get 2 over 2x plus 1. So what do we have? We have exactly that, don't we? Yeah. So the integration of this would be well, it's a bit squashy here. Let's just do it down here. So the integration of this would be ln 2x plus 1. Yeah? Have a look at this one. Let's consider that again. So y is equal to ln x minus 2. So dy over dx would be 1 over x minus 2. So therefore, the integration of this would be, we need a 3 here, yeah? So therefore, we put a 3 at the front here. So it will be plus 3 ln x minus 2. Right, last one. And you're going to do this one using your chain rule. So we're just going to rewrite this as minus x minus 2 to the power of minus 2. So when we do the consideration here, we're going to look at the power above that, right? So y is equal to, if you want to include the sign, you can do, or not. It's completely up to you. So x minus 2, what's the higher power before that? Minus 1, right? So when we differentiate this, what do we get? The minus 1 drops here. What do we get? Negative. So that bracket can be written like that. And the power becomes minus 2. And then we differentiate what's in the bracket. So we get that, which simplifies to minus x minus 2 to the power of minus 2. So if you look at this, what we want and what we have here is exactly the same, right? And that came from a positive result. So therefore, when we integrate this, it's going to be a positive that. So not ln, bracket x minus 2 to the minus 1 plus c. And of course, you could rewrite this as 1 over bracket x minus 2. So what's our next step going to be? To simplify this, all right? So let's just quickly get rid of this and put it as x minus 2 as a fraction like that. Right, so the ln here, we've got the ln here, and we don't have an ln here. So how can I put these two together? These two are going to be ln, and then we add in. So what happens when you add? You multiply. So you get 2x plus 1 in one bracket times by, now here, this 3 is going to go up here too. So you're going to have x minus 2 cubed. Close that, plus 1 over x minus 2 plus c. And that is the full simplification of that. So these examples should cover you for your basic integration by partial fractions. There is also the top heavy, which we are going to be doing next. And of course, when you integrate within limits, okay, where you substitute values in. So right at the end, you'll be given values here, and then you'll have to substitute it in here and leave it in a particular form of ln or something, right?